Today is Higgs Dependence Day, 4th July 2022, and it's 10 years since the Higgs discovery. And that's why we came up with this new paper in Nature where we describe what we learned the last 10 years about the Higgs boson. The Higgs boson was predicted 50 years ago to explain why particles have mass. Particles have different mass, and the Higgs explains why these masses are the way they are. We discovered the Higgs boson, but 10 years ago we were not sure about all its properties. What you can see here is the mass of the particle coupling to the Higgs boson and the coupling of this particle to the Higgs boson. And the theory predicts that this is a straight line, that the mass and the coupling are proportional to each other. Compared to the discovery of the Higgs boson, this uses 30 times more data as that we had so far. And what we can see that indeed these particles lie along this straight line exactly according to the prediction. Here on the bottom of this plot is that the precision that we measure these couplings are already approaching 5%. We can see the coupling of the Higgs boson to the vector bosons and the coupling of the Higgs boson to the quarks and the leptons, and we see the precision is already down to 5% only. And also we can see that the prediction agrees for vector bosons and for quarks. And what I'm personally very proud of is this gray point, the coupling of the Higgs boson to the charm quark. 5 years ago I started with a NWO-VD grant to measure the Higgs coupling to the charm quark, and it was not yet known at the time. And now for the first time we put this point here. For the moment it's still with a larger uncertainty, but it's also nicely along this line, and in the coming years we will measure it with more precision. So we really see the properties that were predicted but that we couldn't yet see 10 years ago. In the legend here you can see the couplings that have been measured so far, the vector bosons, some of the quarks and the leptons, but we can also see the particles that have not yet been measured, the neutrinos, the lighter quarks and leptons, and also the coupling of the Higgs boson to itself. So the coming years during the HLLHC we will hope to measure also the coupling of the particles that are now still white, but that hopefully will also appear on this plot. And what I hope that we learn that this point that we've measured now for the first time will shrink so much that we will also see it actually with the full HLLHC data set in 20 years from now.